Okay, well, welcome everybody. It's March 19th, 2014, and we're here at the Philosophy Club to talk about the liar paradox and other paradoxes. So I have a plan. Let me know if you want this changed, but I thought I would, for the first half, talk about paradoxes, all kinds of paradoxes, like 10 paradoxes. And then for the second half, focus in on the liar paradox and all the subtle material there as an example of a paradox worth looking at in detail. And that you can just speak up whenever you want, just talk up. You don't need to wait until I'm done presenting. Just things on your mind, talk. How's that sound?
Sounds good.
Okay. The liar paradox is produced from the liar sentence, which is the sentence, I'm lying, or if you get rid of the intention to deceive part, it's just this sentence is false. And that's what produces all the trouble when you start thinking about whether that's true or not. That's one of the oldest paradoxes. The two oldest paradoxes that still get attention are the liar paradox and Zeno's paradox. Anybody know what Zeno's paradox is?
Which one?
I just realized that.
There's actually a whole bunch of them, but
Yeah, I don't
Anyone
have
will
enough
do.
brain at the moment to be able to describe it, I'm sorry.
okay.
So,
Somebody is chasing somebody. How about that one?
yeah,
Basically, if you have to keep closing half the distance to somewhere, there's an infinite number of points that you have to reach. So since you can't ever go through all of an infinite number of points, you're never going to catch up.
Therefore, motion is impossible.
Yeah.
Yeah. So that was
And there's also the infinity.
Zeno's
machine
reasoning.
and
Yeah.
Weird.
Sort of a pessimistic conclusion, which is fast things are never going to catch slow things. Right? So Zeno's reaction was, well, so much the worse for reasoning, right? But most everybody says there's got to be something wrong somewhere in the reasoning. Right? We need to diagnose the error, not make the error in the future. So that's Zeno's paradox. There's a whole bunch of flavors. These we are just now talking about this paradox of motion. They had other paradoxes also that didn't involve motion. You know, about 5th century BCE in ancient Greece, and liar paradox about 4th century BCE from a guy named Euclides, pardon my Greek. Okay, now, why are people interested in paradoxes? Not just because they want to solve puzzles, but the idea is paradoxes are a symptom of something, and we want to find out what that is and clear up the problem. Okay? Now, why is it a problem? Suppose I say, okay, so you got a paradox. Why should that bother anybody? Why are people bothered by paradoxes? What do you think?
Because they interfere with what should be happening at that moment in time.
Okay, suppose I say, well, what's happening at this moment of time is that I'm here and not here.
It's conflicting with itself.
It's conflicting with itself, and so what? So it conflicts with itself. I can imagine somebody saying, well, see, some people just don't think you can conflict with yourself, but sure you can. You just need to have an open mind to embrace contradictions. Okay, now that's BS that just came out of Dowden's mouth. What's wrong with that? I don't really believe what I just said. I mean, can't we just live? So the world's contradictory. What's the big deal? Things are so and not so. You catch the... Achilles catches the tortoise and Achilles doesn't catch the tortoise. Oh, you look like you were just about to...
I was about to. I was
Yes.
phrasing it in my head. It's an error in reasoning, but obviously Achilles will catch up with the tortoise. The arrow will reach the target. The motion is possible. But there's some error in our reasoning that does not allow us to conclude that. So in order to have reasoning that we can rely on, we should figure out what the problem is. Yeah?
Yes, yeah. And there are implications of this, which is if you just don't clear up the contradiction and you just try to live with it, then there are consequences for living with contradictions. Contradictions have a certain logical form to them, like L and not L, just to abbreviate English here with a little symbolic logic from Philosophy 60, right? So, like any sentence, L could be the liar sentence or it could be something else. I'm going to use L for the liar sentence later on, but that's why I wrote it on the board. But, so suppose you just say, I'm going to live with L and not L. Well, now let Q be something like 1 plus 1 is 3. Okay? So we'll define Q to be 1 plus 1 equals 3. And I'm going to be able to prove to you that 1 plus 1 equals 3. Or for Q could be the moon is blue, or that Obama's your mama, or you take your pick. Okay, so from L and not L, I can deduce L, right? That follows from step 1. I mean, if two things are true, then the first is. That's the has a fancy name of the conjunction elimination rule, but the idea is if you have a left and a right, then you got the left, right? Okay, now if you got something, you've got it or anything else, right? Like, that is, it's true, you have L or Q. If you have L, you have L or Q. That follows from step 2. And then you could say, well, wait a minute, I deduced L from step 1, but I can do something else from step 1. What else can I get from step 1?
Not
Keep L.
Not L. Yeah. Now, if you've got this principle here, which is if you got the high road or the low road, and it's not the high road, then it's got to be the low road, right? If it's on the left or it's on the right, it's not on the left, it's got to be on the right. So that gets me Q, that principle. That has a nice little name that you may remember, but we won't bother with that. So that follows from steps 3 and 4. This is why there's so much fear and loathing of the word paradox. Because paradoxes are apparently good arguments that lead to a contradiction. And once you get a contradiction, anything follows. So the idea here is you've got to stop this idea that anything follows from a contradiction. So from L and not L, Q follows. And that's the trouble. Because not everything is so, right? Don't we know some things like 1 plus 1 is 3, that's not so? Sure. I have sort of a tricky question to ask you now. I don't know if this is unfair, but who proved to us that 1 plus 1 doesn't equal 3?
Robertson? Or was it the Robert? I don't remember his first name, but the Roberts arithmetic?
Oh, Robinson arithmetic. You're close, yeah. Robinson arithmetic is involved with this. And a guy named Gödel was able to prove that if arithmetic is consistent, it doesn't lead to 1 plus 1 equals 2 and also not 2, then it cannot be proved in that system that contains arithmetic. Can't prove. If formal arithmetic is consistent, you can't prove it. That's one of Gödel's famous theorems, right? So that's why it was sort of a trick question. It demanded you to know that no one's ever really proved it. Unless you add new principles, and there's this guy, Gensen, who can say proved it, but we won't go there. Okay, so paradoxes are to be feared because of this. And they've been very stimulating to people throughout the centuries, since back in the 4th century BCE. They've led to a lot of interesting ideas, and I'm going to talk to you about some of those ideas today. Okay, so let's see. Does anybody know what time it is? Do I have the time? What's the time? Kia,
4:37.
4:40?
you say it's 4:40?
4:37.
4:37.
Nope, wrong. It's 9:40.
Oh, okay.
You mean PM, right?
Yes.
You say it's 4:40? I say it's 9:40. But we could both be right because I'm in Eastern Canada, time zone 5 time zones away from us here in Sacramento, California. Okay, so it's like paradoxical until you realize, oh, wait a minute, if we relativize this to time zones, we're really not in contradiction with each other. So if we just spread our consciousness a little more and realize, oh, there's some factor here that's not being paid attention to, then this time paradox. Now, paradox is really something that the experts disagree on. This time zone is just a little puzzle till you realize that there was just a little tricky move there about time zones. Okay. There's another paradox called the Barber paradox, and I think Barber is not spelled like that, right? Okay, suppose I ask about this. Consider the person who shaves all and only the people who don't shave themselves in Sacramento County. Now, could that person be the president of our university?
Why?
Because he's male and in Sacramento County. Shaves all and only the people who don't shave themselves. Ask yourself this: well, what if the president were that guy? Huh?
He can't exist because he both shaves himself and doesn't shave himself.
Yeah, how'd you figure that out? That he both shaves himself and doesn't shave himself?
Well, he shaves all and only people who don't shave themselves. So if he shaves, he can't shave himself because he only shaves people who don't shave themselves. But
Right.
because he doesn't shave himself, he must shave himself.
He's one of those guys who he shaves. Yeah. So that's a contradiction. Okay. But how about his wife? She could shave all and only the people who don't shave themselves. All and only the men who don't shave themselves. Like, or people. Nope, not people, sorry. Yeah. Or somebody from Chico. So if you relativize this situation to, oh, well, wait a minute, do you mean barber only in Sacramento? Then you got a male, then you got a paradox. But if you mean, well, if we could relativize it to gender, and it could be female, or relativize it to where you are, and you could be out of Sacramento, like in Chico or San Francisco, then no paradox. So, same with like the time zone. If you just bring in other factors, then you can resolve the contradiction. Okay, here's the paradox of reference frames. In this, you can, from your perspective, it can be the case that event A happens before B. But it can also be, not from your reference frame, that B happens before A. Both of these can be true. You can have two events, each happens before the other, providing you're in different reference frame. One reference frame is moving very fast relative to the other. You can see these results. Okay, this is one of the puzzling theorems of the theory of relativity. It actually allows for this. And you would think, wait a minute, time can't be both before something and after something. Yes, it can if you relativize to, in this case, not time zone or gender, but to reference frame or perspective on the world, which you consider to be fixed. Okay. And there is another paradox in relativity theory called the clock paradox, or the twins paradox, or the twin paradox. It goes by 3 different names. And in this, it's got something to do with speed. It's like you got 2 twins, one of them gets in a rocket ship, and then what happens? Twins are the same age, right? So they can set their clocks, say, okay, we're same age, and it's now 5 o'clock or something. Then those of you who've read Einstein's theory of relativity, right, or heard about it, you know that something weird can happen.
The one in the vehicle moves relatively slower due to time moving at a slower pace inside the vehicle, while the twin on the outside is experiencing time at a relatively faster rate,
Yeah,
and the
exactly.
twin is moving.
So 2 twins, one can get in a rocket ship, go very fast, but relative to this guy, this guy's time slows down in my right hand. And when he or she comes back and meets the twin, the guy who got in, or the person who got in the spaceship is younger than their twin. Their time has moved slower. You look at their wristwatch, the spaceship wristwatch, you get off, and it's like out of sync with the wristwatches that stayed back on Earth.